Assalamualaikum student. So after the completion of exercise 10.3, today we are going to start exercise 10.4. Okay, so let's see here what's the first theorem. The first theorem is, if three medians of a triangle are congruent, prove that the triangle is an equilateral. Okay, so let's prove. If the three medians of a triangle are congruent, then prove that the triangle is an equilateral triangle. Okay, so first of all we have to make a triangle that I made already here. Triangle ABC. Okay, ABC are corners or vertices. So triangle ABC. In the theorem they are saying that if three medians of triangle, medians means, okay, the line from B, okay, the line from first angle to the mid of the opposite side is called a median. So the line goes from B to mid of the line A to C. Okay, this is the first midpoint. Its name is Q. Okay, again the three medians of triangle, so it means then other midpoint of the line A to B. The line A to B goes towards C. Okay, this is our line P. Okay, and the midpoint of B to C, this line is going towards A. Okay, so this line is our R. So in the theorem they are saying that if three medians of a triangle, it means if three medians, these three lines of a triangle are congruent or equal in size and same in shape, then the whole triangle will be equal to equilateral triangle. Okay, so first of all see here what is given. ABC is a triangle. Okay, AR, triangle AR, BQ and PC are medians. ABC is a triangle. Okay, AR, BQ and PC are its medians. Yes, these are the medians of this triangle. The intersection point of these medians is O. Intersection point. What is the intersection point? This one. Okay, this one is the intersection point of these three lines. Okay, what is the intersecting point? Where all the lines meet. Okay, so this is our point O. So the intersection point of these medians is O. Okay, so measurement of PC is congruent to measurement of BQ and measurement of BQ is congruent to measurement of AR. Okay, it means the line P to C is equal and same as the line B to Q. Okay, and this will also equal as the line A to R. Okay, so to prove triangle ABC is an equilateral triangle, or AB is congruent to BC, BC is congruent to AC, we have to do its statements and reason. So statements are here. In triangle CPB to triangle CQB. Okay, now we break the whole triangle into two triangles. We consider this one, the triangle CQB. It means this. The line goes from B to Q, Q to C, then C to R. This is our first triangle, and the second is B to P, P to C, C to B. Okay, this is our second triangle. So we are comparing these two triangles, and after comparing we will get our proof of this theorem. So in triangle CPB, to triangle CPB, okay, triangle CQB. QB is congruent to PC. Yes, we have seen in the diagram that Q to B or B to Q is same as C to P or P to C line. So this is given in the diagram, and the BC, it means measurement of BC is congruent to measurement of BC. Yes, because the base line, the line B to C is same for these two triangles, so it is common. And again the measurement of angle 2 is congruent to measurement of angle 1. Okay, the reason is angles opposite to congruent sides. These are the triangles, okay, and the lines that are seen here, B to Q or P to C, or congruent. It means the opposite angles. The opposite angles means these angles are also equal. So it is proved by SS postulate, by side angle side postulate, that these two triangles are equal. It means CPB and CQB. Okay, these two triangles are congruent. Congruent means equal in size and same in shape. Okay, now QC is congruent to PB. We are saying that QC is congruent to PB. Yes, because AB is congruent to AC. Okay, so corresponding sides of congruent triangles. These are the corresponding sides of congruent triangles. Is that AC is congruent to AB? Yes, because A to C is congruent to A to B. The measurements are equal, and the reason is measurement of AC is congruent to measurement of QC. You can see here that Q to C is the half line of the A to C. So A to C, let's suppose A to C is of 10 centimeter, then the line Q to C is of 5 centimeter. So Q to C, when we double the line Q to C, we will get our A to C line. Okay, so here is the point. The measurement of AC is congruent to measurement of QC. Okay, and also measurement of AB is congruent to 2, means double of the measurement of PB. So if we double the line P to B, we will get our line A to B. Okay, because P is the midpoint of this triangle. Similarly, it can be proved that AC is congruent to AB. AC is congruent to AB. Okay, and AB is congruent to BC. BC is congruent to AC, and the reason is by the combination. By the combination. So the triangle ABC is an equilateral triangle. जो triangle है हमारा ABC, वो क्या हो जाएगा? Equilateral triangle, and this is proved. Okay. Now our theorem 2. What is theorem 2? The medians PB, QC and RA of triangle PQR meet in point G. Show that G is the centroid of triangle PQR. Okay. In this theorem, they are saying that the medians. Now you know about the medians. Okay. The medians P to B, the medians Q to C, and the medians R to A of this triangle PQR meet at the point. Okay, you can see here that these three lines meet at the point. Which point? The point G. Now we have to show that the G point is the centroid of this triangle. Centroid means center of the triangle. Okay, center of the triangle. So here is given things. In triangle ABC, PB is congruent to QC, QC is congruent to RA. We can see here that PB is congruent to QC, QC is congruent to RA. To prove G is the centroid of triangle PQR, now we have to construct. So construction is join B with C, that we have already done. B with C, okay, and C with A, C with A, and A with B, and A with B. So we have joined these 3 points A, B, C. Okay. Now here is its statement and reasons. So number 1, PG is congruent to QG, QG is congruent to RG. You can see here that P to G, this is our G point. So P to G is congruent to Q to G. Yes, we can see here that these two lines are equal in size. okay, and same in shape. So these two lines are congruent to each other, and also these two lines are congruent to or to G. Okay, by using definition of median, so medians P, B, Q, C and R meets at point G. Yes, the medians P, B, Q, C and R, G meets at the point G. But again, here is the reason by using the definition of median. Now we can say that B, C, A are the midpoint of sides Q, R, P, R and P, Q. That is given. Reason is given. What the statement? B, C, A are the midpoints of sides Q, R, P, R and P, Q. Yes, the point A is the midpoint of PQ, and B is the midpoint of R and Q, and C is the midpoint of P and R. So this is the given. It means that measurement of BG, the measurement of B to G and C to G and A to G is equal. Okay, so therefore G is the centroid of triangle PQR and triangle ABC. What is this? G. G is the centroid of triangle PQR and the triangle ABC. So we can see that G is our centroid. Okay, and this will be G, not H. Okay. So G is the centroid of triangle PQR and triangle ABC, and this is proved. Okay, so we have done with theorem 1 and theorem 2. Now you have to do theorem 3 of the exercise 10.4. Okay, so inshallah we will meet in our second video. Okay, now in that video we will do exercise 10.5. Assalamu alaikum students. So today we are going to start exercise 10.5. Okay, after the completion of exercise 10.4. So what's the theorem number 1? Theorem 1 is saying that the triangle formed by joining the midpoint of the sides of a triangle is equivalent to the original triangle. Okay, the triangle formed by joining the midpoints of the sides of a triangle is equivalent to the original triangle. Okay, so here is its proof. In the theorem they are saying that the triangle formed by the midpoints, you can see that this is a triangle ABC. Okay, and this is the midpoint of line A to B. What's the midpoint here? The midpoint is D. Okay, D is the midpoint of A to B, and similarly E is the midpoint of B to C, and F is the midpoint of A to C. So in the theorem they are saying that the triangle formed by joining the midpoints, the triangle formed by the joining the midpoint, it means you have to join this one, this midpoint and this midpoint. So after joining these three midpoints, the triangle formed is equivalent to the original triangle. Okay, so I have given the names to the midpoints E, F, D. Okay, and this is our original triangle A, B, C. So first of all, in the triangle ABC, D, E, F are the midpoints of sides AB, BC and AC. Yes, this is given that in the triangle ABC, D is the midpoint of AB, E is the midpoint of BC and F is the midpoint of CAR AC. Since in triangle ABC, F is the midpoint of AC, in this triangle ABC, F is the midpoint of A to C and D is the midpoint of A to B. Okay, so therefore FD is equal half of the CB. FB, the line F to B is half of the line C to B. You can see that the line C to B is bigger than line F to D. Okay, so if we say that FD is half of the line B to C, then this is correct. Okay, so and FD is parallel to CB. Yes, we can see in the diagram that FB is parallel to CB. FD line is parallel to the CB line because these are the same in shape. Okay, so by midpoint theorem we can say that FD is equal CE. Yes, we can say that. What we can say that FD is equal CE. Okay, because when we double this line we will get the line equal to BC line. Okay, so the line FD is equal C to E because C to E is half of the line C to B. Okay, and FD is parallel to CE. Yes, and FD is parallel to line CE. So this is our equation 1. Similarly, we can say that DE is equal FC. Similarly, we can say that DE is equal FC. Okay, and also we can say that the line DE is parallel to line FC. Okay, and this is our equation 2. FE is equal DB. Now the line FE is equal DB. Okay, and also FE is parallel to DB. FE is parallel to BD. You can see here that F to E line and B to D line are same in shape. So these are the parallel lines. Okay, so this is our equation 1, equation 2 and equation 3. Okay, first we compare the line F to D with the line C to B. Then we compare FD to CE. Okay, so FD line is parallel to CE line. Okay, and these are two equal lines. Then we compare DE to FC. DE is equal FC and DE line is parallel to FC line. So after that, thirdly we compare FE line to DB line. Okay, these two are equal and parallel. Therefore, from the equation 1 and 2, okay, from equation 1, it means this and this, we can say that the triangle DEF is congruent to triangle ADF. Okay, what we can say that triangle DEF, it means triangle DEF. Triangle DEF is congruent to triangle ADF. Okay, this is our triangle 1, 2, 3, 4. So from equation 1 and 2, we see that triangle DEF is congruent to triangle ADF because these all the lines are equal and same in shapes. So triangle 1 and triangle 2 is equal. Okay, similarly from other equation, triangle DEF is congruent to triangle DBE. Triangle DEF is equal to triangle DBE because we can see that these are the parallel lines. Okay, and this is FD line is equal to EB line. So this the triangle 1 and triangle 3 are equal. Okay, and again triangle DEF is congruent to triangle FEC. Triangle DEF is congruent to triangle FEC or FCE. Okay, so from these equations, from equation 4, 5 and 6, which equations? From equation 4, 5, 6, we can say that triangle DEF is congruent to triangle ADF and triangle ADF is congruent to triangle DBE. DBE is congruent to triangle FEC. Okay, this means that the triangle DEF is congruent to triangle ADF. Okay, and this is equal to, or this is congruent to triangle DED, and this is also equal to triangle FEC. So all the four triangles are equal. Okay, it means the triangle formed by the midpoint. Joining the midpoints of the sides of a triangle is equal to the original triangle. Okay, so hence this is proved. Now the other theorems are too easy. Okay, and so hope you can do at home. Okay, so your homework is you have to do at home theorem 2 and theorem 3. Okay, your homework is theorem 2 and theorem 3. Okay students, hopefully that you have understand the theorem 1 of exercise 10.5. okay, so this is our last video of this chapter. Allah Hafiz students.